Hi everyone. In this video, I will continue to make demonstrations for QGIS training manual with multiple modules for the QGIS beginner. From the previous video tutorials, you have completed vector and raster analysis. With that, this video will be focused on Module 8 of the QGIS training manual, completing the analysis with raster to vector conversion and combining the analysis lessons. Converting between raster and vector formats allows you to make use of both raster and vector data when solving a GIS problem, as well as using the various analysis methods unique to these two forms of geographic data. So very firstly, in this QGIS desktop platform, you need to open some raster data from the previous videos we just created. So click this data source manager and then you need to find this one. This all conditions simple TIF data. Double click and add, close, and then just zoom to layer. So we will use this raster data for the conversion jobs from the raster to vector and vector to raster. Okay, so I will use this data. So as usual, you need to save this map as a project. So save as, and then lab 3, just underbar conversions. Okay, so save. Then I will make a conversion from this raster data to vectors. So for that, you need to click this last menu toolbar, and then you can find this conversion and this tool, polygonize raster to vector. So click, and then you can open this new window. For that, for the input layer would be all conditions simple. The data we just processed from the previous videos. Okay. After that, you need to name of the field to insert. Okay. So in this case, we will use suitable. And then you need to save this file as your shapefile. Okay, so that is vector data. So saved file, and then on the lab 3 folder, I will save this one would be name of all terrain. Okay, so save. So I will make this conversion with this all terrain.shapefile. Okay, so after that, just click run. And then you can get this vector data. Okay, so on here you can uncheck this raster data, and then you can get this kind of the vector data. Okay, so for this vector data, we can see the attribute table. So open attribute table. On here, you can find our assigned the field name with the shootable. And then in here, from all the values from these rasters, so 1 or 0 on here. Okay, so you can find all the polygons on here. So based on this vector data, we will select the values only 1 for this shootable field. Okay, so in that case, we can open this property layer, and then on this source tab, you can use this query builder to select that kind of shootable things with the, so double click with the just value of 1. Okay, so in that case, just simple this expression. So and then just click OK and apply. So OK. So on here, if you uncheck this all conditions simple the raster data, you can get this vector data. So we need to check the attribute table, so you can find only the value, suitable value would be just 1. So we can get this kind of vector data with the query builder. Okay, so I will save this filtered vector data with the new name. So on here, just right click and export, save features as. You can save with the different name. So click this format with S3 shapefile, then you need to assign the location folders. So on this case, I will just use name of shootable terrain. Okay, so I will save this shape file with the new name. So you can find this shootable terrain. Okay, so based on this vector data, I will make back to the raster data. So back to raster, I will convert. Okay, so again, you need to select this raster tab, and then you can find this conversion and this rasterize vector to raster tool here. So you need to select as an input layer with shootable terrain. After that, you need to select the field with the shootable. And then on this case, you need to select the raster size units with the pixel. After that, you need to assign the numbers based on the QGIS training manual. And then you need to assign for the width number with 837, and then for the height 661. After that, you need to select this output extent. So this is important. So just use this extent from the all conditions simple. This raster extent we will use. So click OK. After that, you need to save this rasterized file with name of so save file, and then name of this one, raster conversion. Okay, so with the TIF file, so save, and then just click run. And then you can find this last conversion, this rasterized file. So if you compare this one, it exactly matched with the size. So if I will change this symbology white to black and then apply, so you can find. So if you can zoom on here some part of that, so yes, this would be exactly matched. If I unchecked this one, you can see this all conditions simple data. So but if I check this one, you can find no differences. So it is exactly matched. So again, back to this property, and then symbology to black to white, apply. Then you can see the exactly matched with this one. So again, zoom to layer. So I will not check this one. So we just convert from vector to raster. Okay. So but in this case, we just erased these 0 values. Okay. So it just contain the 1 values. Also, the reason to use the numbers for the QGIS tutorial provide, you can check with this information from the input raster. We started from this all conditions simple raster. So this grid cell size would be this one. Okay, so this would be number information for our uses for the raster conversion. Okay, so cancel, and then lastly we can get this raster conversion file. Okay, so at this point you need to save the project. After that, based on this conversion job, I will combine this raster-based analysis with the vector-based analysis. For that, I will open the previously created the project. So in that case, I will use vector analysis things. This would be the previous video I just created. So on here, you can find these well-located houses. So in this case, I don't need this layer, so uncheck. And also all these schools, restaurant, load is okay. So land use is okay. So based on that, I will save this map as a project, as a new project with this save as. So in this case, I will just save on lab 3 as combining analysis, combining the bar analysis. Okay, so save. So and then I will open another layer from the previously created. So I will select this vector and then just select this suitable terrain shapefile. So open and then add. After that, you can find this the suitable terrain data is added. Actually, last time we just find this well-located houses considering this the road and schools and other the areas. Okay, so based on that, we will also select this terrain data. So actually we extract this area from the previous raster analysis with the terrain. So in this case, I will combine this the terrain-based data analysis result as well as this vector-based analysis result. Okay, so for that, I will use this vector processing tool. So on this vector menu, you can click this geoprocessing tool with this intersection. Okay, so after that, I will extract from this well-located houses with the suitable terrain. Okay, so in this case, I will just test with the temporal layer. So just leave all the required parameters as a default and just click run. Then you can get many warning message on here. Also, if you check the resulted data with the intersection, so if I select just few of the selection based on this suitable data, only these layers are selected as new layers for the intersection. So actually this would be kind of error from the conversion raster to vector data. Okay, so we need to fix this geometry with the errors from the raster data. Okay, so for that I will firstly remove this test data, and then you can go to this processing and just toolbox open, and then you can just type on the search box with fix geometry. So in here you can find the fixed geometries, the toolbox. So on here, so this would be vector geometry from fixed geometry. Okay, so on here we need to fix this shootable terrain data. Okay, so this is already created one on the rep3 folder. So in this case, I will save this file with the shootable terrains with fixed one. So on the bar, fixed. Okay, so I will make another shapefile. So run. So now you can get this shootable terrain fixed data. So how about uncheck this one? After that, you need to again go to this vector geoprocessing tool with this intersection. So in this case, I will extract again the well-located houses with this shootable terrain fixed data. Okay. So in this case, I will save as this new file named as new solution. Okay, so this would be show file. So and then click run. Since the vector data from the raster data is kind of big, so maybe it takes some time to complete this process. Okay. So if you want to reduce this processing time, you can select only the portion of data from the vector, and then you can save as your new layers. After that, you can do this kind of intersection processing. Okay. So again, this takes some time to complete the process because this would be the vector data would be kind of big, because that is just extracted and converted from the raster data. Okay, so please be patient to complete and finish this processing job. So now it almost finished, so please be patient to complete this job. So it is completed. So close this window, and then you can find this the selected the intersected the buildings. So if you uncheck this one and this one, you can find this the buildings just selected as a new solution. So again, check this land use and this shootable terrain. So you can find these new solutions on here. Okay. So now I will another selections from this layer. So in this case, I will use vector geoprocessing tool with the buffer. This one. So in this box, I will firstly select this shootable terrain fixed one, and then I will adjust the distance as minus 100 meters. And then how about segment with 10? After that, I will save this newly created buffered file with the shape file as shootable terrain fixed on the bar continuous 100 meters. Okay, so kind of wrong, but I will save this one. So just click run. So after that, I will close this box, and then you can find this newly created the buffered vector layer. Okay, so with this vector, I will one more selection for this the previous selected houses. Okay, so in this case, I will use this vector and this research tool, and then select by location, this one. So click. And then after that, I will select from the well located, not the well located, but new solution. Okay, new solution, the vector data from intersect, and then I will use this the buffered the layers for that. Okay, so after that, click run. Then you can get this the selected one. So if you uncheck this one, you can find this the yellow selected the areas based on the buffered area. So in here you can save this new solution with the export and then selected pictures as. After that, I will save as S3 shapefile again, and then in this case I will use the name of final solutions, final answers, final answer. So with this name, and then I will save this one. So just OK. So if you uncheck all this new solution and this suitable fixed, so in this case this would be final solution based on the vector and raster data analysis. Okay, so this would be final solution. So in this case I just used this kind of buffered area from the this suitable terrain fixed data. Okay, so I will check with this one. So yes, so you can find this the well located houses based on terrain and some buffered areas. Okay, so at this point save this project with the save project button. So now you can answer this kind of the question based on this analysis, raster and vector data, okay, on this QGIS platform. So in this video, I have made demonstrations for the use of QGIS desktop using QGIS training manual with module 8, completing the analysis. Including this video, all the 3 modules, that is 6 to 8 of QGIS training manual, have covered the vector and raster data analysis in QGIS desktop. With these my video tutorials, I hope to help the QGIS beginners for learning about the QGIS basics. Thank you for watching.